Good morning everyone. Today we will discuss decimal to binary conversion. In decimal to binary conversion, suppose if we have any values given to us, that is 123, and if we want to convert this decimal data into the binary one, then first of all we have to divide it from 123 from the successive base. Like if we have 123 value is given and the base is 2, then we have to divide it by 2, 2, 6 to the 12, 1, 61, and the remainder will be 1. Here 61 to the 122 and the remainder which comes is 1. Then again we can divide it by 2, the answer will be 30, the remainder will be 1. When we divide 30 by 2, the answer will be 15 and the remainder will be 0. When we can divide by 2 again, the answer will be 7, the remainder will be 1. When we again divide it by 2, 3, remainder 1. We again divide it by 2, the answer will be 1, the remainder again 1. Next we divide it by 2. Now we cannot divide, so the answer will be 0 and the remainder will be 1. Here we have done the successive division by 2 of 123. And after that we can see that when we have to write the answer, this is basically the MSB part, which is called the most significant bit, and this is the least significant bit. So we write the MSB part at first, and after onwards we write the other number. Like in other way we can say that we can write this number from bottom to top. Like first of all the number is 1, the most significant bit is 1, so we can write over here. Next again the number is 1, then we can write 1 over here. Then we have 1, we can write 1. Next 1, 1. Next the number is 0, we can write 0. Next the number is 1, here we can write 1. Next the number is 1, again we can write 1. So we can see that easily we can convert the decimal number into the binary one. This is the most significant bit and this is the least significant bit. And in next part basically we can say that if we have the fraction value also, this is the integer part, and when we have the fraction value is also there, like number is 23.125. Suppose this is the number which is the decimal one, and if you want to convert it into the binary data, then what we have to do, first of all we will take for this integer value we will follow the same funda, and like we can see to 23 we can divide it by successive base, which is 2. So 2 is to divide here 11, the remainder comes 1. Then we again divide it by 2, the remainder again comes 1. 5 to the 10, then we can divide 2 to the 4, remainder will be 1. Next we can divide it by 2, the answer will be 1 and the remainder is 0. Next we can divide, we cannot divide, then 0 and the remainder will be 1. So here again we can say that this is the MSB part or this is the LSB part. So we can write the data from bottom to top, and the answer will be 1, then 0, then 1, next 1, next 1. So this binary data comes for 23, and now we have to solve for the 125.125, which is the fraction one. So when we are doing the binary conversion of the fraction value, at that time we have to understand that suppose this is data, we have to multiply it by base 2, like 0.125 is there and we have to multiply it by 2, so the answer will be 0.250. Here the integer part is 0, this is the important one. Here the integer value is 0, so we can write 0 over here. We have to write this integer 1, whether it will come 0 or 1, whatever the data will come we have to write over here. Next we will take 0.250 multiply by 2, the answer will be 0.50. So again the integer value comes, which is 0. Next we have 0.50 multiplied by 2, that will be 1.00. So now this time the answer will be 1. And next we have 0, if we multiply it by 2, so it will again come 0. So there is no need to solve further. And this time we can write the data from top to bottom. This thing you have to remind. and the answer will be here 001. So we can write 0.001. This value, this binary data comes is for 23, and 0.125 the binary data will be 0.001, which is in the binary form. Now we can see that how can we convert the decimal number system into the octal one. Suppose if we have any decimal value is there like 137, and if we want to convert this decimal number into the octal number system, so what we have to do, we have to divide this number 137 by 8. Like we can say that if we want to convert any decimal number system to any other radix, in that case we have to take the division of that number by that radix successive times. Like if we have the number 137, and if we want to convert that 137 into the octal one, then we have to divide this particular number by radix 8 of successive times. Like we can make a division, 8 1 ja 8, and here the remainder is 5, 8 7 ja 56, here the remainder is 1. Again we can divide it by 8, so here we can divide by 2 and the remainder comes 1. Next we can divide by 8, so here the we cannot it cannot divisible, so here it is 0 and the remainder comes 2. So here we can see that how can we divide it, that number by 8, as we know that this is the MSB part. Here this 2 is the MSB part, that is called the most significant bit, and this one is called the LSB, that is the least significant bit. So at first when we write the data, first of all we will have to write the most significant bit, then we will write the other one. Like here we can or we can say that we will write this data from bottom to top. Like first of all we will write this 2, then we can write this 1, and next we can write this 1. So here the answer will be 2111 into the, which is in the octal form. Now suppose if any fraction part is also given, like if any fraction part like 23.15, suppose this is the fraction part is there, and which is in the decimal form, and if you want to convert this decimal data into the octal one, then what we have to do, again for this integer part we will follow the same funda. Like we have to divide it by 8, 23, so 8 to the 16, then the remainder comes 7, then again we can divide it by 8, then we cannot divide it, so the answer will be 0 and the remainder comes 2. So here this is again, this is the MSB part and this is the LSB part, and we can write the data from bottom to top, so the answer will be 27 for this particular value. Next, if we see that for the fraction one, the fraction data is 0.15, and if you want to convert this fraction value into the octal one, then what we have to do, we will write 0.15 and then we have to multiply it by radix 8. So this is the fraction value, here we can multiply it by 8, so the answer will be, that will be 1.20, and here we can see that this is the integer value. So we can write over here 1, and the fraction part which has come 0.20, we will again have to multiply it by 8, so that will be 1.60. So we will get this value 1, we will write over here, and for the fraction one we will again multiply this fraction value by 8, so the answer will be 4.80. Next we will write this integer value over here, and the fraction part which is 0.80, we will again multiply it by 8, so that will be 6.40, so we can write 6 over here. So after onwards we will do the same procedure, but now we will get the 4 data, that is enough for us. Now we can write the answer. Here we write the data from top to bottom. In fraction part we will write the data from top to bottom. So the answer, which is 27 for this integer one, and for this fraction one we will get the data 1146. So the total answer will be 27.1146, which is in the octal form. So we can see that how we can easily convert the decimal data into the octal one. Now we can see that how can we convert the decimal number system to the hexadecimal number system. Suppose if we have any value that is 2020, and if we want to convert this, which is in the decimal form, and if we want to convert this decimal into the hexadecimal form, then as we know that we have to take a division by 16, by radix 16, and the number is 2020. So when we take a division of this number, then 16 1 is 16, 4 42, 16 2 is 32, then 10 100, 66 is 96. So here the remainder is 4. Again we can divide it by 16. So 16 7 is 112. So the remainder is 14. Again we can take a division. Here the remainder is here we cannot divide it. So and the remainder is 7. So as we know that this is the MSB part, most significant bit, and this is the LSB part, least significant bit. So we can write the data from most significant bit to least significant bit. So here we can write the data from bottom to top. So here first of all we will write 7, then here 14. As we know that 14, A can be represented as 10, then 11, 12, 13, 14, 15, F can be represented as 15, and E can be represented as 14. So here we can write E for 14. Next we can write 4. So here we can easily convert the decimal data into the hexadecimal one. Next, if we have any number which is in the fraction one, like if we have any number 23.25, suppose this is the data which is in the decimal form, and if we want to convert this data into the binary one, we can convert this data into the hexadecimal one, then what we have to do for this 23, we will follow the same procedure. 16 divided by 23, that will be 16 minus 16, 7 remainder. Next we divide it by 16, we cannot divide it, so the remainder will be 1. So this is the MSB one, and this is the least significant bit. So we write the data from most significant to least significant bit, or we can say that from bottom to top. So the answer will be 1 and 7. Next for 25, we have the data 25, which is the fraction one, and if you want to convert this data into the decimal one, then we can multiply it with radix 16. So when we multiply it, 25 into 16, so here the answer will be 4.00. So it is very easy at this time, because we will get the integer value. So here we can write 4, and next whatever the data 00 has come, which is the fraction part, if we multiply it by 16, the answer will become 0. So we cannot multiply it, and finally we write the answer. For 23 we can write 17, and for 25.25 we can write the data 0.4. So easily we can find out the data from decimal to the hexadecimal form. So if you people will also solve, then you can easily, this is very easy, and you can easily find out the answer.